Okay, so it's really my pleasure to introduce Amy Pavel. She's a postdoc at CMU in the HCI Institute, as well as a research scientist at Apple. She's kind of 50-50 at both. She got her PhD from UC Berkeley, where she was supported by an NDSEG fellowship. She kind of has won a bunch of awards, including Outstanding Graduate Student Instructor while at Berkeley. And two, I think, best paper honorable mentions at CHI, which is the premier venue for HCI research. She's published lots of papers at CHI, at UIST, at Assets, at lots of other kind of good HCI places. She's already the co-PI of an NSF Future of Work grant. And yeah, she's worked a lot on HCI and AI for video, which I think is what she's talking about today. So yeah, I'm very excited to hear what she has to say. Take it away, Amy. You are muted.
There we go. All right. Thank you so much for the introduction. And I'm happy to be here, even if it's virtually this year. So yeah, that was an awesome intro. So overall, I create AI-driven interactive techniques to make digital communication more effective and accessible. But today I'll focus specifically on video, which has become one of our most prevalent data sources today. And I really want to make video useful for more tasks and users, and then assure that our future methods of communication will also be effective and accessible for everyone. Oops. So the internet has made it easier than ever to access and communicate information to wide audiences. But the way that we're communicating has rapidly shifted over time. So for decades, we used text to communicate information in forms like articles, how-to instructions, travel information or reviews, and even expert blogs. But today we've begun to replace text with video in formats like explainer videos, how-to demonstrations, travel vlogs, and even video essays. And so the scale of this production and consumption is massive across many fields, including education, work, and personal life. So just looking at YouTube alone, 1 billion hours of videos are watched and 730,000 videos are uploaded every day. And this isn't just viral videos. So when a survey asked 12,000 people to name their main reason for watching videos, 2 of the top 3 reasons were actually related to seeking information. So specifically to learn new things and to dig into new interests. But one problem is that seeking information isn't necessarily what videos do best. So videos can be really helpful if you're just watching and listening to them all the way through. I think they're a really compelling medium because they can capture your attention with the rich audiovisual format. They can provide detail, especially about spatial and temporal tasks like this physical therapy exercise. And they can promote recall, both via the increased engagement and via dual coding of both the audio and visual information taken together. On the other hand, our current methods for accessing video are entirely insufficient for referencing and reviewing the material. So if your goal is as a student to revisit a part of a lecture to study a topic or complete a homework problem, you're going to have a lot of trouble finding that exact place in the video. So here's just an example of trying to find the point in the lecture where someone talks about a Python operator. But to find this, I'll need to scrub back and forth through the video, playing and pausing the video multiple times to hear the audio. And this is all to just find one point. It ends up taking about 1 minute and 30 seconds. To get an overview of all of the key points in lectures, it's even harder. And from interviews with domain experts and from presenting this work, I've learned that reference and review is a crucial task across many people who study videos, like humanities scholars, psychologists, medical practitioners, and even computer scientists. So video is not yet supporting these referencing and reviewing tasks, but that's not all. So some videos block access to information for users who don't have the ability to see or hear the content. So many videos that rely heavily on visual content, like for instance, a classic genre of silent tasty video, they can be entirely inaccessible to millions of blind and visually impaired people. And so this inaccessible media can create unnecessarily disabling conditions for learning. And this is increasingly concerning as more content moves to video. And then finally, if you don't have the appropriate background or regional knowledge, a video can be difficult to understand. It can be hard to interpret the visuals, and you might just need more background in order to understand what you're seeing now. So media is most useful when it supports the goals, accessibility, needs, and context of its users. And this means as an audience member, different types of media might suit different tasks. So for instance, if I'm referencing and reviewing material, maybe a textbook is right. And then I can go back to the lecture to see more information. Or if I'm missing access to the visual content, an audio description, which describes the visual content auditorially, will be more appropriate. And so this idea is also acknowledged by the Universal Design Guidelines for Learning that state there's not one means of representation that's optimal for all learners. And so to realize the potential of the massive amount of media-based communication that we're creating, and assure we don't systematically exclude people as we communicate to broader audiences than ever, it's important to combine the benefits of multiple methods. So for instance, video might be good for some users and their goals, text will suit others, and audio or other methods like links to additional information might reach even more. So my research mission is to make digital communication more effective and accessible for the full range of audience goals, disabilities, and contexts. And my key approach here is to combine the benefits of multiple methods of communication together to reach more people. So far, this approach has led to a variety of work in this area in creating human AI systems to improve communication. But today, I'll focus specifically on a subset of projects that have to do with video. And so before I get started with discussing how we can use human AI systems to increase access for users with more goals, accessibility needs, and contexts, I'll first answer what's hard about providing multiple mediums of communication for people. So your first reaction might be, I'm an instructor, I already have a lot to do, and how will I possibly create all of this content to go together? Well, as a single author, it might take a lot of time-consuming and tedious and repetitive work in order to create another medium for content that you've already made. And also there can be expertise required. So this isn't necessarily a task that's easy to just hire a crowd worker or another online gig worker in order to create the content, because often summarizing or representing the content requires like a very, very thorough understanding of what the domain. On the other hand, there's been recent advances in AI and ML that make us better than ever at understanding the content that's in video. So for instance, on the visual side, we can detect objects, poses, locations, text that's on screen, and scenes. And in audio, we can detect speech to text and silence detection. So all of these help computers understand the content of videos a lot better. And it creates a really exciting opportunity to try to make this information more useful to people. But AI ML techniques by themselves can be a little bit low level, typically for the ones that are quite high accuracy right now. They can have some variable quality, and it's hard to get expert data to train for these tasks. So my contribution look at how we can enable new types of AI-driven interactions that leverage the AI ML techniques. And so to make sure that the systems I build actually improve the experience of authors and their audiences, I take the following approach. So first, I conduct formative work, which includes qualitative and quantitative studies to understand current practice. So this might mean analyzing existing communication that people create, or interviewing experts and people with disabilities to find out what they need. And so this formative work generates new problem insights. And my second step is to do systems research. And so this means building complex interactive systems that embody research ideas. And this leads to new systems that we can then use to test our hypotheses about our research ideas. And then finally, to evaluate the systems to make sure that whatever I make actually addresses the users that I'm targeting. I conduct evaluations, including technical evaluations of the algorithm, but really importantly for HCI, controlled user studies of people actually using the systems to get work done. And so through this approach, my work falls in human-computer interaction, and more specifically, technical HCI, which is the part of HCI that invents and validates new interactive systems to form reusable knowledge about how people and computers interact. All right, so for the rest of the talk, I'll demonstrate my approach throughout 3 core projects: Video Digest, SceneSkim, and Rescribe, and their contributions. I'll briefly discuss some of the follow-on work that resulted from each of these projects and conclude with how we can use findings from these works to improve communication in the future. So I'll start with supporting the user goals of searching, browsing, and skimming in videos. And my core contribution here is interactive video abstractions. And I'll start with how we can support interactive video abstractions for education specifically. And this goes back, this project was published at WIST, which is a top conference for HCI work. All right, so this goes back to our problem earlier that audiences have these reference needs with video, including searching, browsing, and skimming. But of course, video, as I mentioned, is not ideal for this task. If we look at alternatives, YouTube recently added this transcript feature, which is great, but transcripts contain filler words and repetition that can make them difficult to read. And further, it's still a lot to scroll through. It ended up taking about the same amount of time perhaps if the keyword isn't itself present. So unlike composed text, these videos lack content-specific structure. And this means headings, text formatting, and even paragraph breaks that make it easy to identify key information and skim for key points. So in this project, we take structured text, which is great for reference and review, and video, which are excellent for watching and listening, and we link them together to create this interactive video abstraction. And I'll show you what I mean. So this work contributed an interface called a video digest, which breaks a video down into high-level chapter sections and then lower-level section summaries. And each chapter gives you the summary of a key point, and the section contains a text summary that's easy to read through. So you can get an overview of key points or skim for a particular part of the video you would like to watch. And once you find it, you can go ahead and click on the video to play that portion back.
And these are some operators you can do on ints and floats. So there's the typical ones: addition, subtraction.
All right, so in this case, the abstraction is this textbook metaphor, which allows these chapters and sections, and the interaction lets you connect the two together. But the problem is that for a single user, this is really hard to create manually. So if I were to do this, I would need to segment the video into chapters, into lower level sections, and then summarize each section together. And the issue here is that to do all of these tasks as a user, I would need to scrub back and forth on the video for each segmentation and to remember what each section contained in order to summarize it. So the key idea here was that the transcript for lecture videos actually includes a lot of the information that we're interested in. And so I built 2 approaches to help users segment and summarize the video to create a video digest. The first is a transcript-based editing interface to make this task a lot faster. And then to speed it up even more, I investigated an automated plus crowdsourcing pipeline. All right, so just to show you what one of these task-based or transcript-based editors looks like, here's my interface. And what I do is just load in the video I'm interested in making a video digest for, and it automatically gives you a transcript back that is time aligned to the video at the word level. And so I can directly edit the transcript, or I can use the align transcript view in order to segment and summarize the video. And so the first thing I need to do to create a video digest is to create my chapters. And to do this, I just press, I skim for the top topic boundaries in the transcript, and I press a control key in order to segment the video. Then I need to make my lower level sections. So I go ahead and do this again, but I use just a different control key in order to create each section segment. All right, and then finally, I need to summarize the video. So when I click on a section to summarize it, it highlights the relevant text in the transcript. I can just skim this text and then summarize the main points in the introduction here by typing, after 20 years of studying hunger in Africa, I started teaching global development. And then I can summarize the rest of my sections. And I can just export the direct manipulation view to its standalone video digest. So we just saw how we would create a digest using a manual interface, but that still requires a lot of work. And if you're the expert on the topic, it might take still a lot of time. That might be repetitive in some cases. So we investigated an automatic pipeline that involves both crowd workers who are typically non-experts, as well as automated techniques. So the first thing we need to do is segment the video into the lower level sections. And so to do this, I use an algorithm that tries to group together sentences that contain similar types of topics. So I generate each section segment using this unsupervised Bayesian topic segmentation algorithm. And then for each section, I need a summary. Well, I did try a bunch of abstractive summarization methods, and back when I did this work, they didn't work either. But now basically the problem is that transcripts are different than composed text like news summaries and textbooks, for instance. And so the way that we summarize transcripts is different than those types of data that are typically used. And so abstractive summarization is just not good enough quite yet. It also requires some domain knowledge. So if you know something is repetitive within the domain, you might leave it, or to your class in general, you might leave it out. So although we tried that out, we ended up recruiting non-expert crowd workers on Amazon Mechanical Turk to write 3 summaries for each section. And then we only need 1 summary for each section. So we went ahead and had another set of crowd workers rank the section summaries, and we selected the top ranked version. All right, so now I have one summary per section, but we don't yet have our chapters. So all I did is just reapply our Bayesian segmentation algorithm to achieve our chapters. And if we compare what we get from the manual approach and the automated plus crowdsourcing pipeline, what we find is that there's a similar number of chapters and sections overall. So these ended up looking pretty good, especially because we tried to control for making the section segments equal. But in the main difference you can see is that there's a lot more text on the automatic side than on the manual side. And why this is because crowd workers or non-experts tended to include a lot more information than was necessary. So for instance, in this case, I think this is a really simple example where the crowd worker included 2 examples, whereas the expert only chose 1. But this problem was pretty similar across all of the summaries. And then further, the section segmentation was a lot better, partially because humans don't agree that well on what the sections should be. And even if they were incorrect, they might be just a different hierarchy of segmentation. So what we found is that our segmentation algorithm agreed with authors not that much worse than authors agreed with each other. All right. So what it looks like, though, is that we might want to edit this automatic summary we get back. So what you can do is just load it into the interface, and it lets you highlight or change the section titles. It lets you delete section text and overall edit the video digest. All right, so we wanted to know, do our tools actually help experts create video digests? And so what we found is that when people were doing this fully manually, and there did exist some examples that were like this online before we started this work, which was what inspired it. But people who created them reported that it took, hours, or it was kind of a project, an undertaking to create one of these representations for their lecture. On the other hand, our transcript-based editing interface let us create video digests in about 50 minutes for a 20-minute video. And then finally, when we add the automated and crowdsourced plus the editing interface, this went down to 20 minutes of expert time. So just by shifting the expert to work or to where it was actually needed, we got this giant speed up, and we made this a much more feasible task for people to do. But we also wanted to know from the audience perspective, we did all this work to make a video digest possible to create, but do they actually help facilitate browsing and skimming? So video digest is partially also inspired by research on reading, which suggests that this structure will help people find topics more quickly. But we wanted to compare the video digests that we created both manually and automatically to a linked transcript, as I showed earlier, and also the plain video player. And basically what we did is we asked a user to view a video, and we gave them some number of viewing minutes that was much less than the total length of the video. So this is really testing, can people browse and skim for key points really quickly? And so what we did is we wondered how, if video digest would help users identify more key points. And we basically recruited 92 users, and they each viewed an interface for a certain amount of time and then wrote a summary of the lecture. In our evaluation, we compared the summary to a pre-written rubric and determined that if the summary score was higher, that was better. So what we found is that automatic and manually generated digests significantly outperformed scripts and video, which are the current methods that people use to look into video content. But as the viewing time increased, this difference changed. So manual and automated digests were still better at 5 minutes, but at 8 minutes, this viewing time difference is no longer significant. And we can see that the manual and video are almost similar because people were kind of able to scrub around the video and watch enough portions to get an idea of what was going on. So video digests are really great for quickly browsing and skimming lecture videos in a short amount of time, but that difference might sort of change overall. So after we published the results, we also deployed video digests in a computer science class, and students made digests for their lectures. And so we also released some publicly scribed seminars. But what we heard from instructors and people who we scribe seminars for is that the speaker should always be able to edit the video digest, because the way that you're represented as a communicator is really important, especially if something is made public or is intended from other people to learn from. So we learned that basically these digests need to be quite high quality, that the possible misrepresentation that might happen if other people author it, whether they're experts or learners in the topic or not, might be really important. And then finally, you need to include the important information. And so basically what this suggests is that these might be hard to fully automate. And in the future, it would likely be important to have multiple authors collaboratively edit the digest and give certain preferences for the communicator or other people with specific types of knowledge. All right, so in the next project, So in Video Digest, we basically took the video and converted it into this video digest via both AI/ML techniques and expert interaction. And more specifically, to break it down, we used AI and ML to segment the video and link the text to the points in time that it was relevant. We ended up using non-experts to draft the first summary of the videos. And then finally, we had experts just refine the final result. And so this resulted in a few contributions. So specifically, we had this transcript-based authoring tool, which was entirely novel to this work. We also created this hierarchical summarization method that flexibly integrated both AI/ML and crowd work. And then finally, this format called interactive video abstraction will end up being useful later on. And it really takes this domain-specific structure and lets people access videos using that. So the next project I'll talk about applies the idea of interactive video abstractions to an area that has a lot of text available. And that area is film. So in a lot of formative studies or informative interviews with film professionals, including animators, storyboard artists, and humanities scholars, I found that referencing video is a really common task for their research and teaching. But one big advantage is that we have all of this pre-existing text, which I'll talk about in a moment. So in this project, the key idea is that we already have this expert created text. And now the hard part is using automated techniques to link the text together. And what's exciting about this is I think it's more generalizable than just film, but that's kind of the motivating example I'll use for this project. So the three types of text that accompany film are closed captions, scripts, and plot summaries. So these are readily available online for many films, and they each come at a different phase of the movie production process. So closed captions are created at the very end. They give us transcribed dialogue, some approximate timestamps for when that dialogue happened, as well as sound effect information that's meant to help people who are deaf or hard of hearing. Next, there's the script. So the script has drafted dialogue, which is similar to the closed captions, but the script is produced before the video is created, and it has a lot more information about the visual content in the video. So for instance, it has, this is for Star Wars, and it has the locations like Lars Homestead. It also shows character names, in this case, Owen or Luke, and it has some action descriptions like Aunt Beru prepares the morning breakfast. And then finally, after the video is published, it will have this plot summary that's really short and easy to read through, and contains these high-level events and character traits. So so scripts were the limiting factor here, and I was able to scrape about 800 offline and then connect all of these together. So The challenge of this project was finding out how to link each document together to let people search and browse using all of them or anyone that flexibly suits their needs. And so we allowed people to search and browse the movies just using this text. And so first I'll share a short example of how once we have the whole link back to the plot summary could be useful to answer types of film questions that people have. So if I'm a film studies student doing a project about, I'll use Star Wars here as the example. I think it's a lot of people are familiar with it, which is helpful. But if I'm a film studies student, I might have a hypothesis or question about my film, like do Luke's costumes transition from white to black across the first 3 Star Wars movies? So this is something I think might happen, but in order to validate my idea, I might need to watch all of the videos all the way through again. That might be excessive, but I otherwise would need to browse and skim in the videos to find all of the instances of Luke's costumes. So instead, what we can do using SceneSkim is simply select the movies we're interested in, search the plot summary to specifically focus on important story moments rather than all of the movie, and then search for moments involving Luke. And then I can just browse through the results and find important moments in each movie. So here, Luke is wearing white robes. Next in Empire Strikes Back, he's wearing these gray tattered robes. And then finally, in Return of the Jedi, we'll see he has these crisp, polished black robes. So Luke's costume did indeed transition from white to gray to black, and the interface made it easier to answer that question to just surface these key points involving Luke. All right, so to connect all of these together was each automatic. And so to connect the movie and captions, I first achieved this word level alignment by using this existing method that combined the phonemes predicted from text with the audio features predicted from the audio that are specifically meant for speech. And so I found a forced alignment between these, but the existing method didn't work particularly well for movies because there's a lot of this background noise that the data that is trained on doesn't necessarily account for. And so using this existing method, it was actually worse than the closed captions alone. So this was just a small change, but I instead detected moments of continuous speech and then aligned the words that way. And we found we had nearly 100% accuracy. So words were only less than 1 word off, or 0.067 seconds on average using this approach. Next, I needed to align the closed captions to the script. And people have looked at this before, specifically for computer vision. And so we just used a Needleman-Wunsch alignment, which is just this alignment, but tries to find the best alignment between words. And basically, what was interesting here is that only 81% of caption lines had a matching script line. And this changed sort of drastically across all movies because the likelihood that a script is, a scene is yanked from the script or an actor improvises a line is kind of high. And scripts produced closer to the final movie would be better than others. So what we did in the interface is that we tried to surface, we showed this visualization to let people know whether or not a line that they click on is likely to actually have a match back in the original movie, or if we predict that it's likely to be useless to their research purposes. All right, and I think the surprising part is how can we align the script, which is quite detailed, with this super high level plot summary. So that's what I'll talk about in just a tiny bit more detail. So to do this for each plot summary sentence, we want to find a matching segment in the script. And I did this using 2 pieces of information. So basically, we would expect that the plot summary and the script would occur in the same order. So that narrows down the problem quite a bit. And then also that important words in the plot summary should appear at the same segment if that important word is in the script. So tractor beam, for instance, only appears once in the plot summary. And so if it only appears once in the script, those 2 moments should align. So to operationalize this, what we did is split the script into all possible segments. And then to enforce the order stays the same, we used edit distance to assign segments of the script to the plot summary sentences or to no sentence. And how we decided which matched and which didn't was based on the number of important words that these sections had in common, and specifically the cosine similarity of their TF-IDF vectors. So this worked quite well for actions and dramas, which had a lot of unique objects, locations, and characters happening. But for comedies and romance, this kind of doesn't work as well because it's often a lot of interpersonal interactions between only a couple characters. So there's not that much unique content to align on. So in practice, what this means for users is that it will often get them in the vicinity of the content they're looking for. So even though it's not an exact match, people could still easily sort of scroll to the right part of the script once they had gotten in the range. All right, so I shared earlier how we could use the plot summary back to movie alignment, but I'll share just a brief demo of how all of these sort of come together. So for instance, if you're using the script, the most obvious thing we can do is just click on a line in the script to hear it played back. So I'll go ahead and do that.
I seem to have found it.
But a little bit more surprising is that you can also go ahead and click on a location to see it. So here I'll click on a external shot of space. And then finally, I can also search within the script for other useful information. So for instance, one thing that a film producer mentioned to me is that when they're making casting decisions, they'll often look for a bunch of instances of when a character talked in a movie, or when they're animating a new character. This is also important to base it on other animations. So for instance, I can search within the script characters for all moments involving Yoda. And then I can go ahead and see Yoda's lines.
Yeah. He is not ready.
Yoda.
He is too old.
All right. So we evaluated this in two ways. One way is that we assessed a lot of existing queries from literature. So we basically studied literature, found about 9 queries, and then assessed them using our interface. We also invited people who were film scholars into the lab to use our tool and to ask and answer novel questions about all of the films in our data sets. So just for 2 examples of questions. For instance, one question was, one notices in Empire the red lights flashing in the background whenever Han Solo and Leia confront each other. In practice, we could use SceneSkim to just search for scenes involving Han and Leia. And this ended up taking 3 minutes to find out that this is actually not the case. There's many cases in which Han and Leia, it's not a consistent pattern that red lights flash in the background. And then on the other hand, one claim in a book was that the screen time devoted to lightsabers increases throughout the trilogy. So it took only 21 minutes to answer this question, but actually 20 of those minutes were spent watching the movie itself to see how long the lightsabers appeared on screen. Whereas only a small amount of that time is spent searching. And this did indeed increase throughout the throughout the Star Wars trilogy, which was kind of cool. All right. So with SceneSkim, we were able to achieve quality at scale by aligning these existing documents. And I think this is a pattern we see in a lot of domains where we publish different types of content that could have a better alignment to flexibly support user tasks. So I know when I publish a paper, I often include code as well as a video, which might be better if I give a talk later like this one. It might be great if users could link between them depending on their needs, especially code and papers. All right, but the key contributions here were this forced alignment of existing documents, and specifically my summary back to movie alignment was novel. In addition, we found that the domain specific structure let users ask novel questions, even though they were new to the domain. The documents themselves were so familiar that it sort of enabled all of these searching and browsing tasks super easily. All right, so Video Digest and SceneSkim both use these abstractions to make videos that we already use easier to use. But an exciting opportunity is that we can use these interactive video abstractions to enable new ways to use videos. So for example, I created a system to let people give and receive feedback on creative projects by casually, verbally describing their problems with the project instead of typing out the emails as they normally would. So in this project, we were basically able to use video in a place where it had not otherwise been used for this critique task. And specifically, we took a slightly different approach here, letting the expert actually give the critique, so compose or summarize their critiques, and then a non-expert refine the details in a to-do list. All right, so Next, I'll discuss how we can make videos accessible to people with disabilities. And it's important, of course, that people with disabilities have full access to videos as they become a more and more important source of information. And I want to stress that it's really a similar problem as I was working on before. So basically, different modes are great for different types of communication, and the ability to flexibly understand different modes is something that's really important for accessibility. So for instance, as a person who can use a mouse, I might use my mouse to control my computer, but if I had a motor impairment, I might instead use my keyboard or a switch input device. So similarly, for video, I might be able, as a sighted person, to see and hear all of the content, but it's really important that we adapt the types of modes that are available for people who have visual impairments or who are blind. And these numbers, even the demographic numbers, I think, just the ability to provide access where it didn't otherwise exist is really important, but also the demographic numbers were sort of higher than I would have initially expected. So there's 1 million people nationally and 39 million people globally who are blind. And that's not even considering people who have visual impairments who still might rely on audio descriptions of visual content. All right, so my focus here was to create high quality descriptions of visual content for making videos non-visually accessible. And even better than high quality, I wanted to kind of the expert quality. So if you were blind, that you would have as much access to the full content of the video as you would if you were sighted. All right. So this project is about audio descriptions. And so videos provide information, both auditorially and visually. But the visual content particularly can be inaccessible, which adds unnecessary barriers. And so to make videos accessible, professionals create audio descriptions or narrations of important visual content to avoid overlapping important audio content. And so this is typically done only for movies and TV shows because it's this expert professional work. And audio descriptions sort of rarely exist for any user-generated media. And I think it's sort of this giant hole we're currently seeing in the accessibility of communication as we move more to video. So professionals often have to, I also want to clarify the difference between audio descriptions and closed captions. So you might have seen closed captions before, and they basically transcribe in text what appears in the audio of the video, whereas audio descriptions verbally describe what is in the visuals. And so professionals often need to omit visual content or offset the timing of the narrations in order to make everything fit into the gaps that are available in the video. And so I'll share an example of an audio description. And this is a rare description that is available for non-movie and TV tasks, which is why I picked it. But you'll hear a narrator talk first, and then next you'll hear the audio describer talk. So this it might be kind of surprising if you haven't heard one before. Right.
It takes a village to maintain and operate a place like Mount Rainier National Park. What role will you play? Who will be the future of Mount Rainier National Park?
Job titles appear including trail crew, archaeologist, engineer, climbing ranger, and more. Future rangers. Children wear uniforms for different park jobs. Linnea.
I'm a future archaeologist.
All right, so we saw that the author here omitted details like Linnea's safety vest and offset the timing of the descriptions to fit. And our interviews with 7 audio description professionals revealed that this was a really common challenge, and that timing was the crucial element to audio descriptions. They also told us that it was a really expert task in that they often had to study a domain of a video before they wrote their description. So for instance, if they were writing a video about cricket, it might take specialized domain knowledge to describe the objects appropriately. And then further, they would work with the production team of the media to make sure they're describing it in a way that the author of the media would like to be described. All right. So first, to create audio descriptions, audio description professionals identified gaps in speech. And so they would note the start and end time of each gap. Then they would describe the visual content. And when they went to record the visual content, oftentimes there would be too much content to fit in the space. So the recordings would be overlapping with each other. And then so finally, they spent a lot of time editing down the descriptions to fit. So this meant revising the script of their descriptions and offsetting the timing to make everything fit between the narration. And this could take up to 10 times the length of the video itself. And this iterative process is really time consuming and tedious and isn't necessarily the most fun creative part of the work. So my goal was to enable audio description experts and even novices to create audio descriptions efficiently. And the key idea was to optimize the descriptions by jointly shortening text and lengthening source audio to fit everything in the time provided. So the idea here is just to let people draft their descriptions and to automate all of these tasks that are kind of annoying to do around the editing and refinement of the description. So using Rescribe, which is my system, people can input their source video and visualize the speech and audio gaps along the timeline. We also transcribe the video and we can show the gaps in the transcript. So authors can navigate using the gaps in the timeline or the transcript and then script their description. So for instance, I might type the title of the video. And then a montage of bright footage from Ojai to set up the opening shots. And Rescribe interactively updates the timeline so people can visualize about how much information they have left. And then authors record their descriptions.
Shots of lavender in a farmer's market. Red flowers against a white house and blue sky.
And what's really important here is that authors only need to do this drafting and recording part once for the video. And everything that happens from here automatically edits that one recording together. So authors can click create to automatically format their descriptions to fit and then listen to their results.
Title, Gabby's Guide to Ojai. A montage from Ojai. Shots in a farmer's market. Red flowers. A courtyard and a pool. Gabby bikes along a path. Close-up of French fries. Gabby drinks sangria. Gabby and Thomas sit on a couch.
Hey guys, Gabby.
Authors can then further edit their descriptions without re-recording, and they can lock a description in place. So Rescribe rendered these three types of descriptions. It can render extended descriptions, which blind users in our studies did not like. These basically pause the underlying audio in order to fit all of the author's speech. And typically this can be really disruptive. Inline descriptions, so this is the type we listened to earlier, they play alongside the audio, and Rescribe does this by automatically shortening and adjusting the timing of the description text. And then finally, Rescribe renders a new type of audio description. So once we were already optimizing this automatically, it enabled something entirely new called an extended inline or inline extended description. So I'll go ahead and play this back. And this subtly loops the underlying audio to fit more of the original description. And it breaks the sync with the video. So you'll see intentional pauses in this example.
Title, Gabby's Guide to Ojai. A montage from Ojai. Shots of lavender in a farmer's market. Red flowers against a white house and blue sky. A courtyard and a pool. Gabby bikes along a path. Close-up of tater tots and French fries. Gabby drinks sangria. Gabby and Thomas sit on a couch.
So that really subtly included way more information by subtly looping the underlying audio. So I'll cover a few of the algorithmic methods that powered Rescribe. So first, Rescribe identified speech and silence in the input video by transcribing the video and classifying speech using a CNN-based approach. Second, users described the video, and Rescribe automatically aligned the script and the recording together at a word level. And then finally, the bulk of where Rescribe happens is in this editing step. So Rescribe can edit descriptions by shortening the text, by deleting a description, or by adjusting the placement of the description or extending the underlying audio. And so I'll just briefly share an intuition about how this works. So for each description, we generate a set of candidates using a rule-based approach that was informed by guidelines for professional audio descriptions. So for instance, we might have Gabby and Thomas are back in their living room, or and Gabby are back as options. And so in practice, this ends up with about 200 to 300 plus candidates per description slot. So to select which of these candidates we'll include in the final description, we score candidates based on their informativeness, coherence, edit quality, and placement. And I'll just briefly touch on what these mean. So informativeness is based on word probabilities to include words that tend to be important to the video and the description itself. edit quality impacts the edits, coherence is a GPT-2 based perplexity score, and edit quality has to do with the audio. So ultimately, we put all of these into an objective function and use dynamic programming to solve. So we basically found that novices were able to author descriptions easily with less overlapping errors. Blind and visually impaired audience members liked extended descriptions the most, and conversations with experts revealed that people really liked that this automated the tedious parts of the task. And Rescribe really was motivated by providing expert quality descriptions, which ultimately led to 2 follow-up projects that looked to encourage accessibility at other stages of the video editing process, rather than doing all of the accessibility work after the fact. So specifically, I published 2 papers, Dakai 2021, about augmenting search to help people find expert described things already, and then also embedding descriptions in their scripts originally. All right, so my core contributions have been these interactive video abstractions and the high quality descriptions. And these systems that I've built have informed how we might build human AI systems in the future. So specifically, I've learned that what works well when automated is often when low-level interpretation is required, there's high human disagreement, or it's a non-expert task. We might have crowd workers do this now, but in the future, that's a really great place for pure automatic techniques. On the other hand, I think about what needs to be done by humans in terms of high context tasks. And finally, how humans should do these tasks should be authoring tools that provide task-specific recommendations and editing tools that consider the full range of audience capabilities. So when I support new goals, accessibility needs, and contexts in the future, I'll apply these findings to support new domains by creating these tools myself and democratizing the creation of human and AI communication tools so people can do their own types of alignment for human interactions. I worked mostly on visual impairment, but there's a lot of opportunity for supporting communication with cognitive or mobility impairments. And then finally, I think it's really important to have representative data labels for human AI interactions. So I found that it really depended on who described the content, what type of content, what type of descriptions we would get back, and making sure that those are a high quality and not necessarily a non-expert content agnostic task is really important. So I will investigate social systems that account for context and algorithms to translate or combine labels for different consumers. And with that, I will conclude my talk. Thank you all so much. And I will also leave up this slide to jog your memory for questions. And I look forward to hearing more. All right.
Okay, awesome. Let's thank Amy virtually. Fake claps. Yeah, so awesome. Great talk. We have some time for questions.
I have a question.
Yeah.
Amy, thanks for the talk. It's amazing. So maybe I'll start with the last study you talked about, the Rescribe, where you support, I guess, video authors to create quality videos. To me, so the kind of video that you show in your talk is very descriptive in the sense that it's like a scene, you introduce the phrase.
Yes.
So what if people do the more functional tasks like how-to videos? Do you actually see the improvement that this kind of author support will translate to the end user's performance in terms of the actual task performance?
Yeah, that's a great question. So I haven't investigated actual task performance or recall yet. And it's something I'm looking at because blind users' perceptions of how accessible content is doesn't really account for these unknown unknowns, right? So there might be something that happened in a how-to task or in that sort of nice descriptive video that blind users don't even know that they're missing. So I think that's super important, and especially when we think about tasks. In this study specifically, we did look at a how-to video was one of the videos that happened to be included. It was about mixing clay pigments to create pottery. And that ended up not really being the problem. When we saw errors, it mostly came from when people used the system differently than expected. So for instance, if they used a different grammatical construction than the way that audio descriptions are typically written by experts, that ended up being a problem. But I think because Rescribe tried to preserve terms and descriptions that were sort of repeated throughout the video, it tended to do, and it sort of removed adjectives more and adverbs more commonly than it removed other types of things. So I think the answer is I don't know. It definitely requires a little bit more study. And I hope that, through having people create these types of things, we can get more data about what types of descriptions we're creating, and then ultimately how well those actually work to support people in their tasks. But yeah, that's a great question. I think how-to videos and educational content, we just don't have that many principles for how audio descriptions should be. And I think, incorporating the experience not only of experts, but also like blind people who have experience doing the task, I think would actually be important if we really wanted to make how-to videos entirely accessible to blind people. Yeah, that's excellent question.
Thanks.
So this question is pretty far afield.
Yeah.
But in the physical world, we have standards for accessibility, right?
Mm-hmm.
And the ADA is either super prescriptive or incredibly wonderful, depending on what your take on it is.
Yeah.
So what's the outlook and what are the obstacles to creating accessibility standards for video content? And I'm not looking for a legislative opinion. I'm just looking for a burden on production and is this something that could be, are there minimum standards and would they be useful?
Yeah, so I think, part of this work was trying to figure out what the standards should be for social media, for user-generated videos. So there do exist standards. So like the WCAG has sort of these really high-level description standards that are like, you should include description when possible. Don't include, prefer inline description over extended description. So these really high-level sort of prescriptive things that people tell people to do as standards, but they're not necessarily tied to the content, except for film. So there exist textbooks about how to write audio descriptions for film, and those don't exist anywhere else. So I think one thing that it would take is just getting a lot of so part of my work has been studying, like, what do experts currently do when you give them the new tasks, and how do blind people perceive those results? And so I think it takes this iterative process of having experts do these tasks that they haven't been previously asked to do, like describing this user-generated content, and then interviewing blind people about their own preferences to figure out what the methods should be, and then ultimately combining those into a set of standard principles. And I think what principles do is sort of two things. They might tell the producer what they should do, but they also take this audio description task, for instance, from being like this super specialized knowledge to something that maybe someone else could create. So if we think about image descriptions online, there's a lot of standards that people use to create image descriptions that are a little bit more descriptive, at least, than videos. So yes, I think it will take a lot more iteration on and data collection and user interviews to sort of fully understand what should be the case, and then maybe write those into a set of standards or principles that people can apply. Yeah.
Thank you.
I have a question. Oh, Ben has his hand up.
Thanks for deferring. Just because I used my Zoom hand. Yeah, I had a vague question about.
Yeah.
It seems like some of the approaches have models at their middle, right? So like the video, when you were talking about the comparison of the closed captioning versus the script, there was the comparison was using Needleman-Wunsch, and Needleman-Wunsch, basically has some model assumptions behind it, and you can choose different model assumptions, like linear gap penalty or affine gap penalty and things like this. So and then further, you also show the objective function, right, for the audio, adding the audio captions. So do you have some thoughts on the degree to which these are models that can or should be like learned, and that whether whether, you know, that has an advantage in the sense that if you learn it, if you learn the model, you might learn something from the learned model in the sense that you're learning what the people are trying to do in that system.
Yes. Yeah, that's a great question and something I end up thinking about a lot. So the way I sort of inform what models I use are kind of based a lot of times on expert guidelines for how these documents are created or how they should be created. So for instance, that's how I got my objective function, was sort of by analyzing best practices. But I think what it doesn't account for is new types of users who use those interfaces. So for instance, when I had novices use Rescribe, the objective function totally didn't suit their types of text. I mean, it ended up working, but it wasn't optimized for that. So I think systems, I think one limitation I run into as someone who investigates sort of new tasks and interactions is that there doesn't necessarily already exist a lot of data. But I think the fact that I'm building these systems can be really helpful to collect kind of rich data about how people do these tasks and eventually learn these objective functions over time to support more users. Yeah, it's a great question. And I think, you know, it's a little different for every different project, but Rescribe like definitely fits into where I think that could be a lot better for sure.
Thank you.
Yeah, great question.
So my question is just, again, perhaps out of left field. So, you know, in data science, they have a lot of complicated high dimensional modalities that nobody really understands. And even people doing the analysis, which includes video, but also other things, right? And I was just wondering if you or your community have thought about whether this kind of stuff, possibly with annotation help from somebody who understands the modality, could help with that. I mean, maybe it's related to explainable AI to some extent, but
that's a great question. So I think what I've looked at is trying to figure out what do experts already think is important about a domain. So based on the artifacts that they create or text that they've written about how to do it, and then try to surface those aspects for users. But I think your question is really interesting because once we perhaps you know, surfacing those different types of explanations for users could be connected back to these features and dimensions that we don't understand. So for instance, they kind of give us this lower level like input into the video, into what people think is important. So I do think that that could be used to maybe as explainable AI to further maybe expose links to underlying content. And I think how that's done would probably depend on domain. So I think that would be really interesting to explore for one of these, for a domain where I know expert text exists, like you know, medicine or film, and see maybe if that could be an approach.
Okay, great, thank you.
Thanks.
We have maybe time for one more question if anyone has one. Oh. Okay, well, let's thank Amy again.
Awesome, thank y'all.
Great, and have a good rest of your Friday, everyone.
Thank you so much.
See you all later.
Would it be possible to connect over maybe like LinkedIn or somewhere if we want to understand